My name is Jeremy Masner, and we're going to spend the next 60 minutes or so talking about the potential for devices to interact with the mesh. This is something that's kind of near and dear to my heart. I have a lot of devices. Some of them are up here today. And the truth is they just don't work together well enough as they should. The scenario that I try and get working all the time, for example, is sharing photos with my family. I have a 2.5-year-old son, and I have a 95-year-old grandfather. It's pretty amazing to have both ends of the spectrum in the world, and I like to try and keep them connected. So I take lots of pictures of my son, but it turns out to be very hard to get them to my grandfather because he's not a technology guy. We solved that problem today by getting this thing called a printing mailbox that Hewlett-Packard sells, where it's a printer that sits in his room, and it connects to a custom service, and it actually pulls that service for pictures. And when a picture shows up, it prints it out for my grandfather. But it's not as seamless as I'd like it to be. First of all, I'm sure we're all familiar with the problem of just getting the camera connected to your device, right? You take your camera, you take the pictures, and then, well, how do you get your pictures onto your PC? And then how do you get your pictures from your PC to the rest of your family? Can you email it? Well, maybe it's too big to email 10 pictures, and you have to scale them down, or you post them to a website. So that's kind of one end of the problem. But then this amazing device that my grandfather has is really this whole separate service. And of course, you want a device like that to have an authorization list. Not just anyone should be able to spam a printout to my grandfather. So there's a whole separate administration interface where I have to add people in. There's a separate management interface where I see if it's out of ink. And so it works, but it's not as easy as it should be. And it makes me do more work than I'd like to. I'm a lazy guy. I want it just to work. I want to take a picture and have it show up for all of my friends and family, including my grandfather. So what we'll talk about is the potential for devices to interact with mesh to enable those kinds of seamless experiences. A lot of what I'm going to talk about is going to be forward-looking today, so I'll warn you that not everything is possible. I'm going to give you a behind-the-scenes look and say not all the demos are real even, but they're going to give you a flavor for what I think is possible and what we hope to inspire you guys to do. So I hope you walk out of the session really thinking about three things. One is I really hope you are just inspired about the potential for mesh, for live services, for the Azure Services Platform, for software plus services, and for your own devices and applications that you're building, thinking about how they can interact with mesh. The second thing is I hope you have a good understanding of what it actually means to be a device in the mesh. We're going to go into some technical detail that's not quite in the SDK yet, but I want to provide you a pretty clear understanding of what it actually means to be a mesh device, so you can evaluate whether that's the right thing for the devices that you're building or not. And then the third thing is I want you to understand that some devices might not actually have to be capital D devices. And we'll get into that later. But there really are different paradigms for interacting with mesh, and you can do a lot of interesting things without having to be a full mesh device. So let me just take one more poll quickly. How many of you actually work on software or services for a device of some kind? Oh, fantastic. OK, the fourth thing you should take away then is that we want your feedback. We are not quite, we don't have this available in the CTP today, all the device infrastructure. We're thinking about how to make it available through some kind of a device adaptation kit going forward. We're pretty early in that planning, and we would love to get your feedback. So I'll take your questions. You can email me. You can post to the forums. You can submit speaker feedback. Any of those things would be great. All right. Where are we? I should have put the title, You Are Here. Just a quick recap. It's been a long week at PDC. So you remember on Monday, we talked about the Azure Services Platform, this sort of core layer of Windows Azure OS in the cloud, some services on top of that cloud. One of those services is live services. When you dig into live services, I hope you've seen a picture like this before in some of the other talks. There's a lot of interesting services on the bottom, and then these sort of user-centric notions on top of users, devices, applications, and synchronization. And again, just to recap, in our vision of software plus services, the devices are really the key to making it happen. If you don't have good device support, then you just have services. The key is to connect it with users wherever they are. So it's your stuff, your way. All your data, all your applications, the people you share with, on whatever device you happen to use, whether it's a PC, whether it's a Mac, whether it's a phone, whether it's a picture frame like or a printer like my grandfather. That's his device. So without devices, the software plus services vision doesn't quite come together. I'm going to be a little bold and assert that we can divide the entire universe of all known devices into roughly these 4 categories for the purposes of interacting with mesh. And this is going to kind of guide how we go through the rest of the talk here. Let me see if I can use this fancy little zoomer thing. I don't know if this helps or not. Forget it. We'll just talk. You see on one side we have creators. So I think this is a pretty obvious class of device. Your digital camera, maybe you've got one of these devices that records video. They have these USB devices now where you plug it into your cable box and it'll be your digital video recorder. These are devices whose primary job is to get content and make it available to you. You don't interact with the device that much necessarily, and you certainly wouldn't sit on the device and edit a document or something like that. Its primary job is to get stuff into you. So that's the creator category. On the opposite end of the circle, of course, are consumers, devices whose primary job is to play back content to you. So great examples would be your media player, your picture frame. There could be many others that you're thinking of there. But again, they're not devices where you do a ton of creation or interaction. You're mostly there to play back media. In the middle, there's an interesting set of categories, devices that I don't have a good name for. I'm calling it processor right now. We could think about a better name for that. But if you imagine this as a pipeline where content's coming in one end and out the other end, there's plenty of content where you actually want to transform it in the middle. You want to perform some kind of operation on it. So one of the canonical examples is transcoding, right? If you're actually taking a 20 megapixel photo on your camera and you're going to play it back on your Zune, it doesn't really make sense to sync 20 megapixels down to a screen that's, I don't know, 200 by 300, something like that. You actually want to be a little bit intelligent about it and say, why don't we transcode that picture down to the correct resolution for that device? So that's one sort of category of processing. Another one might be backup. People ask us a lot about how backup is going to work in the mesh. So that would be a great sort of processing device in the middle that watches all the changes that go through, archives them off, gives you a full version history, and makes them available to you for later use. Another example here might be a streaming media server. So maybe you don't actually want to sync the photo all the way down or your music collection all the way down to your device. Maybe you just want to kind of stream it on demand. That would be another good role for that processor device in the middle to play there. And then outside of those sort of special class devices, there's the rich endpoint. It's the device that anyone who's used mesh today is most familiar with. It's your PC. By the end of this talk, you should be able to use your Mac and your mobile phone also as rich endpoints. But these are really the interactive devices, the ones that you sit at, you're spending a lot of time at. You're creating, you're editing, you're saving, you're viewing. You really want the full functionality of the mesh there. So roughly, I divide the world up into those four categories. And we'll talk a little bit about how you think about where your device fits in there and how each of those kinds of devices interacts with the mesh. Before we do that, my slides remind me I was going to show a quick demo. It's probably overkill for everyone here, but since we're video recording it, maybe people watching it have not actually seen mesh live. Let me just do a quick review of what devices look like in the mesh today. The internet connection here is miserable, but it'll pick up in a second. So again, devices we present on this notion of the device ring, which is going to be populated. Look at it count down. Any minute now, we're going to see all the devices on the device ring. And we give the user this concept of managing their devices in a way that makes sense to them. Well, let's look at another view of it down here. Here's another view of my devices using the client software. So I'm able to see all my devices. I'm able to see some status about them, whether it's online or offline. Here's one that's offline and also is going to need some attention when it comes back online. We have a little bit of information there about it. And it's also a central place to do some interesting management tasks. So for example, connecting to devices. Hey, here's my device ring. The device ring's cooler because it spins. Yay, spinning. We have some real Ajax wizards here. So again, here's the one that's offline. Here's the one that maybe needs some attention. And it's a place to go ahead and launch some connection experiences. We also, starting with some recent builds, we have another area called the device profile page, which today is not perhaps as useful as it might be, but this is a placeholder. We really want to make this richer over time. So it's a place where you can see transient properties of the device, persistent properties. So you could imagine having lots of properties about the size of the display on this laptop, what kind of software it's running, what it's been doing lately, is the disk full, is the disk not full, and some interesting news about the device. Again, much more to come here. And in fact, I'll show later in the demo some interesting stuff. And then the way you manage these devices, you can do it through the device ring. You can launch some simple management tasks. But really the way that you decide how you want a device to work is on a folder by folder basis. So what I do is I go to a folder, one of my mesh folders like this one. I go over to the devices area here on the pane. And I can tell, hey, on this folder, I want these two devices to interact with this content. I can, of course, manage and I can make this decision about any of my other devices that are floating around in my in my mesh. But really the central way we think of managing these rich endpoints is on a folder-by-folder basis. And that's going to be a key distinction we're going to talk about later. There are some devices, I think the rich endpoint is a good example, where it makes sense to have some management on the device ring and then some management on that folder-by-folder basis. There will be other cases where you actually just want one central way to manage the whole device at one time. OK, let's get back to our slides. So this is how we start to think about, if you've got a device, what's the right way for it to interact with mesh? What's your mental model for how it participates? There's a set of things that a device might want to do to contribute into the world of the mesh. So certainly the first two are pretty easy. Device might want to see what's going on in a folder. It might want to get the latest changes, and it might want to provide changes into that folder. That maps pretty well to the creator and the consumer device paradigms. But there are also some more sort of complex things a device might want to do. It might want to actually subscribe to real-time notifications. So rather than having to poll every so often and say, what's changed, it might actually want to subscribe, have the mesh service notify it and say, hey, there's something new here. You better go check out what's going on. A device might want to be able to publish its transient or its persistent properties. So again, we saw that on device ring. Sometimes you want to know, is the device online or is it not online? Is it ready for a remote desktop or is it not ready for remote desktop? Is it capable of storing new material or is the hard drive full? Those are some of the sort of transient properties. And then again, the persistent properties that I think are going to be very interesting on some devices are things like screen size. You really want to know, if you're carrying a music player that happens to have a screen, what size that screen is. So you can, for example, make intelligent choices about how you transcode some of the photos that go down to it. So that might be interesting for a device to do. And the last thing that might be interesting is communicating with other devices. This is critical to us in two of our mesh platform experience scenarios. One is remote desktop, live remote, where one machine is able to remote desktop into another. Another is synchronization, for example. If you really want to do a good sync experience, you want your devices to be able to talk directly to each other. Especially in the home network setting or the corporate setting. If you've got these two devices here and a device changes on this one, the last thing you want is to have to push it all the way up to the cloud and then have this device also go to the cloud to get that changed file. You really want these two devices to be able to speak directly to each other, peer-to-peer, and communicate about that file. To do that, to do it right, you want to do it in an encrypted way so that users feel secure and that their data is not just floating around out there. And so to do that, you need to have a little bit of extra information so the devices can communicate. I don't know why my cursor's a blue circle. And then there's also a question, in addition to the device functionality, a question of how the device actually wants to present itself to the user. How should the user perceive this thing? And this is really sort of the distinction I was getting at before. And it sort of boils down to, do you want this device, is the mental model for the user that it should show up on the device ring and it should be a thing that you see and interact with both in the device ring and per folder? Or is it a separate sort of application or interface for managing the device? And I'll give you one example there, as we talked about before, on that processing unit called a transcoder, right? A device, if you have a device in your mesh that's doing transcoding of photos, I don't really think it makes sense to show up on the device ring. I'm willing to have a conversation about it, but my guess is that users don't really want to see a transcoder on their device ring. They don't want to see every time they go to a folder, gee, should I synchronize the transcoder with this folder or not? And what does it mean to synchronize the transcoder anyways? Its job is just to sort of change stuff in the middle. So for a device like that, it might make more sense to actually view it as sort of a separate application. And the user goes to the transcoder mesh application, is able to configure all their settings and see their status there. So there's a bit of a decision to make there. And there might be some cases where you actually want both these things to happen. We'll talk about one of those later. So if you want the sort of very simple, hey, I just want to go pull the folder and tell me what's new, I want to push something into the folder, or if you really think that the right paradigm for you is to not show up in that device ring, but is to be a separate application, then I'm going to propose that you basically treat your device like an application. I'm calling it the app paradigm here. But I think that's actually the right mental model, is that even though it's a device, obviously, the way you're presenting it to the user is an application. It's a service that applies across your mesh rather than a device within your mesh. If you need some of these richer capabilities, or you actually want to show up in the device ring, then you do have to actually present yourself as a device to the user. And we'll walk through some of the differences here, because this is, again, something that we're still thinking through ourselves, and we're still trying to get the guidance right. So I'll tell you how I think about some more of the differences here. Always handy to have a table to show you what's different between two things. Really, the biggest difference between the application paradigm and the device paradigm is whether or not you have a mesh device. And I'm going to say that in that voice when I mean capital M, capital D, a very particular thing about what a mesh device is. And that's really by that denoted by the line registered device there. And we'll talk about what it means to be a registered device. In the application model, you are not registered as a device. You're treated as an application. In the device paradigm, obviously, you are treated as a capital D device. So when you're an application, your authorization is governed by delegated auth, which maybe some of you have done in the lab, or you've seen one of the other talks this week about how delegated authorization works. Again, we'll talk about that quickly. As I mentioned, the user experience would be through a custom app. Applications don't really show up for management in the device ring or on a per folder basis. And device horsepower is a little bit of a funny way to say it, but you don't have to have a very smart device in order to interact in this app paradigm model. You have to have a device that knows basically how to do some HTTP gets, maybe an HTTP post or put with an authorization header. But it's not very complex. It doesn't take a lot of processing power. It doesn't take a lot of battery power. And so there are some devices where that itself might actually be the governing factor, and you really want to build it in that model. On the flip side, obviously, the device, as I said, has a registered device. The authorization model is a little bit different. We're going to go into it in some detail here so you understand how that works. The user experience, as I say, is managed by what we call the platform experience, the device ring and per folder. And the device horsepower is a little bit higher. It's probably not all the way up to high, but we do expect the device to be able to get some credential information. We expect the device to be able to post a bunch of presence and status information, to be able to refresh that information, to be able to respond to redirect codes from the server or timeouts from the server and know how to behave appropriately. So we do expect a little bit more out of the device to really participate there in the right way. I'm going to spend the next couple slides talking about the difference between these two authorization models. And this is mostly just so you understand how it works under the covers. I know when I'm evaluating a new technology for the first time, I like just understanding what's going on. So we'll spend a very short amount of time on delegated auth because there are a couple other talks you can go watch online that'll fill in that story for you. And then we'll talk a lot about this notion of device authorization and device mapping because as far as I know, that's not documented anywhere yet. Delegated authorization, how many people are familiar with this? OK, so we'll spend a little bit of time on it. The basic idea of delegated authorization in the live services platform overall is to get away from the password anti-pattern, as people on the blog sphere like to call it. The password anti-pattern is the idea that you go to a site that says, hey, I want to access your data. Please enter in your username and password. And they actually expect users to give their username and password to this site. What's even crazier is that people do it all the time. But once you've done that, that application is now impersonating you. And you have to kind of trust that that application is going to do things you're comfortable with it doing. That it's not going to go spam all your friends or delete all your data or whatever, go sell your data to the highest bidder. So we think that's not a very good pattern. We prefer instead this pattern of delegated authorization, which is leaving the user in control so that the user can say, I would like this application to have the ability to read my photos. And that's it, not any of my other data. Just read my photos. And then the application basically gets this delegated auth token. It can present that token back into the live framework and the live services and say, hey, the user promised I could read their photos. And the live services say, OK, you can read their photos. But if they try and do anything else, we say, nope, you're not authorized. The other advantage, of course, to this approach is that if the user later decides not to trust that application, they revoke the token, and now the application no longer has access. If you do the password anti-pattern, you end up having to change your password, which is, again, not a very intuitive approach. So basically, this is a highly, highly simplified version of what's going on here, but it gets the idea across. The user goes to the app and says, hey, I want to use you. The app has to go to live services and say, here's this user. They say they want to use me. Can you make it all happen? And what happens is live services at that point communicate directly back to the user. The app is not in the way there. It's a direct communication between our services and the user where we say, here's this app. Here's who it's signed by. What kind of permission do you want to give them? The user can say, hey, here's what I intended. We sort of make up a token that encapsulates all that stuff, and then we hand that token back to the application. So if you are going to be interacting with the mesh and live services and the live framework using the application paradigm, this is the process you'll go through to get authorization. Again, the BB22 session from, I think, Monday I know I had some slides on this, and then Arash's BB30 session from yesterday or the day before had this also. The sessions are all posted online 24 hours after they complete. So by now, almost all of them should be online. You can go check them out to get more details on that. That was the app paradigm. Let's talk about the device paradigm. And I mentioned before this notion of I'm going to use my voice here, the mesh device, the capital M, capital D device. And I want to dig a little deeper into what that really means to be a mesh device. So let's try fancy technology again. First and foremost, it means you have a device ID. This is really the key to making all of the mesh scenarios with devices work in our book. So again, we want to get the authorization right. We want to keep the users in control. And so the way we do that in the device case is we actually give the device its own, essentially, account. So in the same way that I have a Hotmail account, and when I want to interact with live services, I log in with my live ID, or maybe I use this new federated connector service we talked about, and I can log in with my Microsoft ID. For the device to do anything with mesh and this live services, it too has to log in. And it literally has a username and a password, and it presents those things to live ID using one of these special device accounts. So that's a critical thing to have there. Another critical thing for a device to have in this world of mesh, actually I'm going to jump orders a little bit and go over. Well, all right, I'll do it in the order I meant to. Another critical thing to have is a notification queue. So again, we talked about the importance of devices being available online to get these kind of subscriptions and notifications, the ability for one device to communicate with another. For that to work, you must have a way to reach that device. So we have a queue service that's part of the live services. I think maybe it's called a notification service in some of the documentation. But when a device comes online, it actually establishes a queue. Now we have a way to reach that device. Another important thing are proper. Oops. That didn't work. Let's try that again. Woo, that's much better. Properties for the device. This is not strictly required, but it's pretty useful. So again, we talked about persistent properties being things like what kind of device is it? Is it a laptop, or is it a picture frame, or is it a camera, or is it a printer? Those are useful things to know. What's the screen resolution, et cetera. Transient properties are pretty important also. The most important transient property, of course, is the device online or not? If you don't have that information, then you have no way to reach that device or interact with it. But there are a bunch of other transient properties. You saw some kind of surface in the device ring. Is it available for connection? Does it have the remote desktop connectivity installed or not? Is it available for sync or not? Lots of stuff there. We've built a special device connectivity service that's built to handle these things at very broad scale. They're meant to be transient. So it's something you've got to change it every minute. That's fine with us. You can go ahead and update that service. We scale quite well in that scenario. There's also, by the way, part of the trick to scaling something like that is to put a time to live on everything. So a transient property tends to have a 5 or 10 minute TTL, so that if you haven't refreshed it in 10 minutes, we just pull out your entry. So this is when I was talking about the differences in horsepower between the app paradigm and the device paradigm. This is one of those examples. If you publish your device connectivity, you've got to remember to refresh it according to the TTL. Otherwise, it's just going to fade out from the device connectivity service, and no one's going to know you're online anymore. And then the last thing that's pretty interesting here is this notion of device mappings. And this is really the key to authorization for devices. So we talked for applications about this delegated auth token. The same thing logically actually happens with devices. We let the user delegate authority to a certain folder to a certain device. But the mechanism is quite different. What we do is on each of these mesh objects, and again, for those, it seemed like most people have been to a session, so they probably know the term mesh object. But that's the unit of scope for one of our items. If you look at a shared folder, that's a mesh object. If you saw the crossword application running one of those mesh applications, that's a mesh object also. Each mesh object has it has a membership list where we control what users have access to that object. But it also has a device claim list, and that's where we control what devices have access to that list as well. So that's sort of a mapping between, there's a resource in the directory service that says this is this device and this is its properties. We make a claim with a user, so the user says, hey, I use this device. And then we put that claim on a folder when the user wants a particular device to have access to it. So those are the critical things there. And I'll just show you I'll walk through a little flow here of how this works, and then I'll show you some of it in some of the XML so you get a sense of it. So what I'm going to do is spend a few slides just walking through the sequence diagrams. We sort of saw a simplified one for delegated authorization. Again, just to give you a sense of really how this stuff all works under the covers, because I think this will help you have a sense of what it really means to be a device. So the first step is provisioning the device, which to me means getting the device identity created and associating it with the user so that you're able to do the next interesting steps. So the way we go through to provision a device is we ask the device to generate its own key pair. You can generate that however you want. And then it takes the public key for that and it goes off to the live identity services and says, hey, here's my public key. Here's the username and password. Create an account for me. I should note that this particular protocol is not yet documented in our SDK. We're working on it. It'll be available coming soon, but you won't find that information out there today. And what the identity services, we all affectionately call it IDS inside Microsoft. I don't know if that's a common term outside of Microsoft, but we all call it IDS. IDS comes back and says, great, you have an account, you're signed in, here's a certificate from me that represents your identity. And now you can present this certificate to any service that speaks to IDS, and that service can look at it and say, clearly this is a valid device that's signed in. Our device takes that certificate and wraps it up in a SAML token, and again signs it with its own public key so that it's clear that it came from that device. And then we go off to the live services, over to the mesh directory, and we say, hello, I'm a new device. I'd like to create a device resource for me. So in the same way that we create a user account when you're provisioning a user, we go ahead and create a device account. I'm not going to go into too much detail about our whole approach to REST and open protocols, but we use REST-based open protocols, so when you want to create something, you do a post. It's all just HTTP requests back and forth. So we post into the directory and say, hey, create me a device resource. The directory comes back and says, hey, you got it. Here's a reference for you for in the future how to get back to your device resource. So it'll be something like /device/ some string of numbers and letters. And it returns back some handy links and tickets for further authorization. We'll talk about that in the next slide. And at that point, from there on up, we have a device resource in the mesh, and we know how to authenticate. That's a good first step. The next step is to associate that device with the user. In the live services, we have a model where devices and users don't have to have a one-to-one mapping. They can be many-to-many. So users can have multiple devices, but also interesting is that a device can have multiple users. This is critical, we think, for the home scenario, where you've got one shared PC and mom and dad and brother and sister are all logging in there. So we actually want to associate that device with a particular mesh user account so that we know that that user really wants that device to be part of their mesh. So what you do there is, assuming the user had already signed in, I didn't show that here, but if the user signs into Live ID, we also get a user ticket back. So the device would take that ticket and hand it off to the directory service. And just as it looked at the /device area before, this time it looks at the /identities node of the tree. That's where we store user accounts. And we say, hey, get me the user account that corresponds to the guy who signed in with this ticket. Mesh returns back a bunch of information about that user. And then we do this thing, we create what we call the device claim. So we put into that user's space this little blob of XML that says, this user has claimed this device. Is that making sense? Roughly? OK. So that's now, by the end of this stage, the device exists. It's claimed to a user. Hey, that's the wrong machine. Let's try this one. Great. The next thing that's going to be interesting if you're a device is actually coming online and getting your notification queue set up. As we talked about, most of the interesting scenarios in the device paradigm revolve around having a notification queue, having some online connectivity information. So sort of I'm starting a little bit from scratch here. We would, again, take that SAML token and go back to the mesh directory and say, here I am. I created an account before. I'm back. And mesh says, welcome back. Great to see you. Here's some information. And what it's going to return back is a ticket, a mesh ticket now that can be used to speak to other live services. For various reasons, the live services expect one of these special mesh tickets, not a regular IDS ticket. So you take your IDS ticket to the directory service once, and the directory service gives you back a ticket that you can now use to speak to the rest of live services. So we return that ticket back so you can make a bunch of other calls. Then we give you back some links. We say, hey, we've created a notification queue for you if you want it. We've created a place where you can post device connectivity entries if you want it. And of course, in this case, we want both of those things. So we take the link that comes back from the notification queue. We do a post to it, which is essentially the way of telling the notification service, hey, I'm listening. I want to hear about notifications. And what we return back is the URL where notifications are going to come to. And I'll explain how that works in just a second. Now that we have a notification queue, we can tell the world that we're online. It's important to do it in this order, because if you do it in the other order first and say, hey, I'm online, but you have no way to reach me, it's not that effective. It's a better idea to say, I got my queue, and then you go ahead and post one of these device connectivity entries. And essentially, inside of here is just an XML blob. There's some limitations on how it works today, but the model is you could post whatever properties you want up there. So you could say, I'm online, I'm ready for sync, I'm not ready for sync, I'm ready for remote TV recording, whatever it is you want to express. You post up in that device connectivity entry. And once it's up there, anyone else in the mesh is now able to read that device connectivity entry. They're able to see what's happening there. So once that's done, now you're ready to get notifications. There's an entire talk right after mine on how our notification process works, so I won't go into too much depth here. But essentially, when we created the notification queue, we gave a queue URL back to the device. And the model we use for doing notifications is long-lived HTTP connections. Because of all the network infrastructure in the world, it's not very common that our service could just go pick a random device and ping it. It's very unlikely to reach out to that device. So instead, we ask the device to reach out to us. And what it does is it does a get against this queue URL. If there are no notifications, we keep that get open as long as possible. In the real world, we see it usually times out after the 30 to 60 seconds because your various routers and your firewalls and your gateways don't like keeping connections open. But if there is nothing waiting for my device, then the get times out. And if the device cares about getting notifications, it'll just do another get on that URL, and it'll wait for it until it comes back. If something does happen, someone's trying to reach me, then we will send that notification as a response to the get. So we really do push notifications out, but to get across firewall boundaries, we require that the device is coming up to us rather than us coming back down to the device. And as I didn't really quite directly say it, we do use one central notification channel for every notification across mesh services. So you don't have to open more than one notification queue. You set your one of them up, your one queue, and then anyone who wants to reach you goes in through that URL. So if you wanted to get real-time notifications, you just sort of spin into a tight feedback loop here. You do a get. If it times out, you do another get, and then until you eventually have some body in the response there. OK, so now we have our device claimed by a user. We have it online, and it's listening. The last step is to actually make sure the device has access to something. Because right now, and this is not necessarily going to be something that every device does. For example, remote desktop, if we stopped just here, our live remote would work just fine. The device would be part of a user's account, so there's some authorization for me to know that this device and this device are able to talk to each other. The device is online, and we could actually do remote desktop. But if you want to do things like sync, where you're accessing some of the other mesh objects, then you have to grant access. So that works pretty easily here. What you do is, again, you get the user's identity information. You actually have to get your device claim back out for that user. So again, because of this binding between devices, multiple users to one device, you don't want to just walk up to a mesh object and say, anyone on this device can access this mesh object. We actually want to do that sort of tight binding and say, this mesh device, when used by this particular user, is the only one who has access to this mesh object. So I got to catch up with myself here. Blah, blah, blah. We get the device claim. And then what we do is we walk up to the mesh object that we care about, and we post to this thing called mappings. And I'll show you how that works in a second. But we actually create one of these device mappings. And it's the presence of that device mapping that lets the device have authorization to that mesh object. So again, just as for a user, you would look in the members feed to see does a user have access. For a device, you look in the mappings feed to see if a user has access. So one of the really cool things about our approach to the open sort of RESTful programming model is that if you sit down with a network sniffer, you can see how all of this works. I'm not going to do it now, live. But here's something I did with Fiddler. When I first claimed this machine, I went ahead and just ran Fiddler. And you can see, actually, this whole... on this machine it says. You can see this whole series of things that are going here. So here's the device. It's getting its device ticket. It's going ahead and creating the notification queue and the device connectivity entry. Here's a bunch of cases up here at the top where it's pulling that notification queue to see what's going on. Here's the user logging in, getting their identity ticket. There's the device claims. You can really see this whole process. It's really amazing. It's just open. Go ahead and do it. I encourage you to explore. The caveat is that you'll see some things that are not yet supported in this particular CTP. So you have to always act a little bit with caution. You're essentially reverse engineering what's going on here. It's great. It's very informative. Just don't bet on it. If it's not documented in the CTP, that's for a good reason, which means we're likely to try and change it or refine the process a little bit more. And then once that's all done, of course, you can use this thing, the LiveFX resource model browser that's part of the SDK, so you can actually go see these things. So here, for example, I'm going against my accounts directory. And I'm using one of our internal test servers because, as probably some of you know, we're actively upgrading the live site right now to beta, so none of my demos work against the live site. So we're going against a site that no one else has access to. So sorry about that. Ignore that URL. But what you can see is these are the identities for me as my identity as a user. And you can see that I have these device claims, which are linked over here. And then if I go ahead and drill into device claims, and if the cloud is actually up, is that it? I couldn't tell if it changed. I guess it did. What you see are here are the device claims for my identity. Every device gets an entry here. And these are all my different, you can see the friendly names. So here's the device claim for my work desktop. Here's the one for my laptop. Here's the one for laptop 2, which is this machine. And then the device claim has a sort of mapping, as I said, between the identity and the device. I would love to show you the device resource, except that I'm not authorized to. Right now, Data Model Browser, the Resource Model Browser, is running under my account. So I'm able to go to the /identities node, and I'm able to see about my identity. If I click on the devices node, I'm going to get an unauthorized. And that's exactly by design, because the device is just like another user. You have to sign in with the device's username and password to be able to see all those device resources. So there's a stunning example of authorization in action. We just don't have the right thing wired in here for me to type in the device ID. So again, lots of neat things when you do this kind of open protocol-based approach to services. You can get lots of good insight into the system. So I encourage you definitely to play around and explore with all those things. Where are we here? OK, now we get to do a fun demo. I'm going to see if all this works. This is a little bit duct taped together, but hopefully it works here. So what I want to show is a demo of actually tying all these things together. I'm going to take a picture with the camera, and you're going to see it sort of propagate through the mesh. Two things. The first is, this is, as I said before, a conceptual demo. And anyway, if you've been paying attention during PDC, we switched to this blue slide, which says future concept. It's very dim up there up top. I know. It's funny that I guess they didn't quite want people to know, but they sort of wanted you to know up here. So again, I just want to be totally open. This is stuff that you can't necessarily go do today. I'm happy to try and show a conceptual demo of how it works. But don't expect you can go in the lab and make this work. The second thing is a quick word from our sponsors. I've gotten a couple companies who are interested in working and prototyping some of this stuff with us. I'll highlight the hardware they gave me, but they all asked that I give a big caveat, which is I am not making any product announcements. What I'm doing is showing a neat demo. We're engaged in early discussions with lots of these companies. Some of them are here in the room today. You can ask them questions afterwards, but I certainly don't want to pretend that I'm announcing any of their product plans or any of our product plans. These are just some ideas of how these things can work together. So let's take a look at our world of devices. We have a digital camera running an iFi card. How many people know iFi? A few. iFi is super cool. It's the world's first wireless storage card. So it's an SD card that's sitting in the camera. It behaves like a normal SD card as far as the camera is concerned, but it actually has, it's Wi-Fi enabled. So when I take a picture on this card, it's able to broadcast it out over Wi-Fi. So that is a great way to solve the problem of having to plug the cable into my camera every time. So that's one key part of the demo. I have a NAS device made by a company called Marvell. Marvell is, I don't know, I'd call them an ODM from the phone world. But they're the guys who make the chipsets that go into everybody else's NAS devices, network attached storage. So they have this thing they call system on a chip. It's a CPU, it's a bunch of logic, and it powers up a NAS. So they loaned me, as you can tell, they're not exactly a consumer electronics company. They're a hardware company that sells chips to other people. But this is what they gave me to borrow. I got a printer from Hewlett-Packard, which is super cool, mostly because it's small and I could carry it on the airplane. So thank you, Hewlett-Packard. And then I have a picture frame, which I had to buy myself. So no credit to those guys. That's the way it goes. You know, you have a chance and you pass it up. So let's see if this thing works. Give me half a second. The picture frame, this is actually a cool picture frame. So it's wireless. And someone actually at the company owned it before me and configured it to connect to their Flickr account. And so every 10 minutes, it tries to go to their Flickr account and download all their pictures. So half a second here. I'm going to make sure it's actually connected to my mesh. Sorry, hang on. Someone took a picture of me doing nothing? Is that for real? Okay, let's see if I can get the demo done before the picture frame decides to download a bunch of pictures from Flickr. Okay, picture of my boy being entertained by his aunt. But let's take a picture and have it sort of percolate out through the mesh. Let's switch to the demo machine. Oh, sorry, this demo machine. Okay, we have a camera. Everyone smile for the mesh. Yay! Okay, if everything goes well, the Wi-Fi card in here is going to go ahead and communicate with my mesh. Hey, look at that. Okay, so now we've got the first part of the problem. Yay! Thank you, Wi-Fi. So that's a pretty cool first step. And if we go over here to my mesh folder, we see that you're all live and in person. Ooh, what's happening there? Well, the printer is mesh enabled. It noticed, it subscribed to this folder. And so it's assumed this is the printer in my grandfather's house. I want to print out that picture I took of all of you immediately because I know he loves to see my audiences. He feels so good when I have a full house. It makes him really happy. So in beautiful full color, that should be coming out. Our picture frame is also subscribed to the mesh. Also subscribe to the mesh. Okay, picture frame. Hey! Ah, look at that! Hooray! Thank you. Okay, we made it without the other interruption, which is great. And then last, but certainly not least, although probably least sexy from a demo perspective, it made it to the NAS. So there's my NAS. It doesn't look all that impressive, but it's sitting as a device that's on my network, and I basically told it to go ahead and archive and make backups of everything in that photos folder. So now it's on my trusty terabyte worth of storage, and I know that if something went wrong, I deleted the file by accident. I've told the NAS never to delete files, only to add files. So everything's always there and backed up. And just to give a little more love to the Marvell guys, because that's really not the most beautiful of demos. But this device really does have some horsepower, right? So it's they have this whole sort of web system on a chip, and you can do account management and permissions and blah, blah, blah. So it really is a rich device, which makes it very great for interacting with the mesh. Oh, dear. Look at that. Yay. Okay. I won't tell you how much of a miracle it actually is that that all worked. Let's just say it's always that easy. The mesh makes things so simple. Okay, that was the really fun part. Now the rest we're going to go into the description of sort of how I propose each of these devices might really work in the mesh going forward. I see people leave the cool demos done. I don't blame you. It gets boring after this. It's true. I'm going to try and make it fun, though, so stick with me here. Let's talk about the picture frame. It's one of those consumers. I think the mental model is really for the picture frame is to be an application. I don't think you really want the picture frame as a device that shows up in your device ring. It's a pretty uninteresting device because you can't do much with it. You really just want to be able to say, hey, I want the picture frame to print out, maybe all photos, or maybe any folder where I've added my grandfather's email. Not that he has an email, but I've added my grandfather's account as a member to maybe 10 folders, maybe some folders I share with the family. I just want to give access to this service to go pull those photos and stick them onto the picture frame. So we actually, as it turns out, have a neat model for doing this. We have a live service today called Frame It. If you go to frameit.live.com, you'll see this service. And I'm going to read their marketing statement so I get it right. I can't memorize it. Frame It is all about enabling users to experience and share their up-to-date digital photos and content anytime, any place, and on any device. It's a really neat service. So one of the reasons that you have to do that is you take a picture frame manufacturer like this. They're actually not that interested in being only mesh enabled. They want to be a general broad purpose wireless device. I don't blame them for that. There are lots of interesting services out there in the world. So you have two choices. Either you make a way for this picture frame to speak to Flickr and Facebook and Mesh and Snapfish and blah and blah and blah, or you make the picture frame pretty simple and you put a service in the cloud. Software plus services. We love it. Glad to see these guys love it too. That's exactly the model that they did. So the picture frame knows how to talk to the Frame It service, and the Frame It service is where you go, you log in, and you configure all these different data sources. So that's a really nice model. We think that's exactly the right way to work. And in this world, the Frame It service would be the application that would have delegated auth into your mesh. So you as a user would say, I grant Frame It permission to read this folder, and then all the magic happens. So that is pretty cool. The camera has the iFi chip in it. iFi is another great software plus services example. So the iFi card can either communicate directly with my PC, or it can communicate with the cloud service. And you really, I think your mental model, you could go either way with this one. The cloud service is one fine way to go. It works from anywhere. That's an advantage. I don't have to be at my home PC. And again, it would be the exact same thing. I didn't draw the words delegated auth in there. But you'd go, in fact, if you use the iFi site today, this is exactly what happens. They say, hey, pick from this list of 20 services that you want to publish your photos to. In fact, if I checked, I bet you it's the exact same list of services that the Frame It site has. It's a pretty common set of things. So we would love to see a world where there's a mesh service up there, and you say, hey, I want to publish my photos into mesh. You choose which folder it goes into, you delegate the authorization, and it works. But because we have software runtime, what we call the live operating environment running in local mode on the PC, there is another way to integrate in with mesh for this kind of device. And it's actually a much lower barrier to entry. If you've used the mesh client, and again, most of you have, you know that mesh folders just kind of map onto your hard drive, and they show up as regular folders under your usual documents root or wherever else you want to put them. And we've done that very intentionally because we wanted to enable applications that know nothing about the mesh to interact with us. We thought it was critical that you be able to go into Office, open up Word, type a document, and save it into that folder and have it show up in the mesh. So in the same way that Word has no idea about live mesh, it has no idea about live services or identity or authorization, it's just putting stuff into a folder, you can actually, in this model, have iFi do the exact same thing. Say, hey, take the picture, shove it onto the PC into this folder, and mesh will just take care of the rest. I'm not actually sure I can enumerate the pluses and minuses of each approach right now and why you might pick one over the other. We're still thinking about it. But there is some nice flexibility there. And again, that's enabled because, like us, the iFi team is thinking a lot about software and services together. Hooray. OK, the NAS. This one's a little bit trickier. Because on the one hand, I sort of argued before that it's something like a transcoding device or a backup device. You don't really want on your device ring. You don't think of it as a device you interact with. You think of it as a service that's interacting with your whole mesh. So going down that path, you really want it to be using the application model. So you could imagine there would be the Marvell backup mesh-enabled web application that you could access through your live desktop or through your client, where you just sort of pick and say, hey, these are the folders I want backed up, or my backup policy is, make an archive every month, whatever it might be. That works well from a user model, but from an actual scenario model, I really want this device to be able to communicate with these two devices. Because when it's doing backup, as I sort of said before, the last thing I want is for this guy to have to do his backups by doing round trips to the cloud every single time, especially if I'm in a home setting and all my devices are at home. Why should this device be going up to the cloud? I really want it to talk to these two devices right here. To do that, you have to have a mesh device. I'm going to try and use the voice again. It has to be a capital D device because it has to have its own account information, it has to have its own device connectivity entry, and its own notification queue so that it can communicate with these devices and say, hey, I have authorization to access those particular devices and sync those files across. So I think there's probably a little bit of a hybrid model on this guy where he's got an application, and he's also probably a device, but a device that's marked to not show up in the device ring. So already my beautiful world of 4 simple classes of devices is starting to get slightly more complicated. That's how it always works. But I do think there's going to be some scenarios like that where he needs the access and you just don't want him to show up to users. And again, he sort of has the choice of whether he wants to speak to the cloud or to the other guy's clients. Then we have the printer, Hewlett-Packard PhotoSmart A637. Thank you, Hewlett-Packard. And you know, I'm going to argue that this guy should be a full mesh device, at least for this scenario that I care about with my grandfather. I want this device to be online all the time. I want to be able to see if it's online or offline, if it's healthy or not. I want to see things like ink levels. I turn out, as you can expect, my grandfather not so much good with changing ink cartridges. So it's helpful for me to know, is he full of ink? Is he out of ink? Does he have paper? Does he not have paper? I'd even love a sensor in the paper tray. Not that this paper tray worked that well, but imagine if it hadn't fallen to the floor, that there was a tray here, and it could tell me, hey, there are 10 printouts waiting that your grandfather hasn't picked up. Or it says, oh, it's empty. Your grandfather picked up all the pictures. So that way, if there are 10 or 15 there, I could give him a call and say, hey, Poppy, time to pick up the pictures. So this is sort of one concept of how that might look in the device ring. I showed you a very boring device profile page before. Here's what would be a slightly more exciting device profile page. Again, this exists only in Photoshop on our graphic artist's desk back home. But the idea of this thing really interacting in a rich way and being able to say, hey, here's what's going on with this device, and here's what's happening with it. So I think that's pretty cool. You know, you see all kinds of, I don't know if all the coolness is evident, but you know, even things, you know, it sort of tells you the ink cartridge was replaced. So maybe I get a notification in Seattle that the ink cartridge is low, and I call my cousin and say, get off your rear, go over to Poppy's house and pop in a new ink cartridge for me. And then I actually get confirmation that that thing has happened. So that's handy information to have as part of this device. But wait, there's more. I have a device I didn't show you because it, again, doesn't fit into my beautiful world of 4 devices. So I proposed yet another device type, which is this interesting sort of embedded or surrogate device. So how many people have heard of the Intel remote wake technologies? A few. How many people have heard of Wake on LAN? Most. OK, good. In the world of software plus services, our vision is blah, 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 your stuff, your device, anytime, anywhere. Today, for that to work, your device has to be on. So it's really nice that if my PC at home is on, I can remote desktop to it. But the reality is I remote desktop to my PC at home maybe once a week. It's not that often. And to get that to work, I have to leave the thing turned on all the time. As an environmentally conscious guy, it hurts me deeply to know that my PC is sitting on all day while I'm at work. On the 1 in 7 chance I might actually want to access it. So our friends at Intel have done this work with the remote wake technology for PCs, which is basically a network card that's able to stay awake when your PC goes to sleep. And because the network card is awake, it's able to listen to interesting notifications. So this is very similar, for those of you who raise your hand for Wake on LAN. That works today, right? You send a little magic packet to your PC and it pops up. But that only works if you're on the same hub. Which is not at all useful in the broader software plus services internet-wide context. So Intel has done a bunch of work to make a little agent that can go out and connect to a service and listen for HTTP or SIP messages. And they kind of came to us and said, hey, we've got this thing. Do you think it would make sense with mesh? And we said, absolutely, it's going to make sense with mesh. Again, no product announcements. We're exploring exactly how much sense it makes and when we can bring it out to the market. But I want to show you a conceptual demo of how that would work. This is actually the flakiest part of the demo. So hold hold tight here. And it's nothing to do, it actually is because, well, you'll see why in a second. So here is my device, number 2. Just move everything out of the way. And for the people watching this on video, sorry, it's not going to be very interesting. So this device right now is on the mesh. It's online. You can see it's got some interesting stuff here. And what we're going to do is put this device into sleep. Goodbye, device. We'll wait till it beeps. There we go. OK, so this guy's asleep now. But because we're in a world where we have Intel remote wake technology, we're actually able to keep the device online. So let's just show quickly the demo, then we'll talk about how it works. OK, so this is another bit of a smoke and mirrors demo here, but we've rigged up a device ring that would express this. So we've got our device. Look, we've even got the printer. Our graphic artist did a great job. Thank you, Russell, wherever you are. Fun things there. But hey, here's this laptop. And you notice it's actually expressing the fact that it's online, but we've used maybe some of that extensible XML in the device connectivity service to say it's online, but it's in kind of a special state. It's sleeping. So yes, you can connect to it, but you have to be a little bit patient. So I'm going to hit connect, and some magic is going to happen. And what it's done is, look at that, it's coming up. It has actually sent the remote wake over to this machine. Thank you. I couldn't figure out how to make it actually show the screen when it woke up. That would be so much more impressive. But it did wake up on its own. And we're ready to connect. And this is actually Mesh's fault. I don't know if the device is back online. So let me just look. Well, all right. Theoretically, it's online. So let's see if that happens. This has been running consistently slow. So while it's thinking about that, if you guys see the magic thing pop up, let me know, and then I'll finish the demo. Let's talk about how it works. Come on, baby. So this is actually it's a pretty simple idea, but again, it's this new kind of device that doesn't fit into one of my other 4 categories. It's basically this embedded agent, and it's a surrogate. So the mesh services do all their usual, the mesh runtime does all of its usual stuff, talking to the live services. It establishes the connectivity and the queues, and it gets all this information up here, and it's just acting like a normal agent, like a normal device. When I tell the device to go to sleep, we do a little bit of a handoff. And so the Intel Remote Wake Technology agent is actually a smart configurable agent. We pass off all that queue information and the authorization information to this agent, and then we go to sleep. And what the remote wake agent does, the remote wake technology agent does, is listen on that queue URL using my authorization. So it's basically pretending to be that laptop. And when a notification comes in, such as me trying to connect, boy, this is so sad. I'm going to try this one more time. You saw it wake up. That's certainly half the battle. But let's see if we can connect. OK. Well, so much for that part. We'll try it one more time in a second. But when I try and connect, the mesh service just returns a regular old notification on the same queue that it always does. In this case, rather than going directly to the mesh runtime in the PC, it ends up going to the Intel Remote Wake agent. That agent says, ooh, a notification. I should probably tell the application that originally configured me on that channel. So it wakes the PC back up, as you saw, and it sends the notification off and says, hey, buddy, something happened. So it's not really a device that a user would think of, but it definitely pretends to be a device to the mesh. And we think this is going to enable a whole bunch of nicer user scenarios where you'd care less whether your device happens to be in a full power state or not. And in fact, you can be a more responsible eco-citizen and keep your devices in the low power state and still have them always available. So that's a neat trade-off, and we're looking forward to figuring out how we take that thing forward and bring it to market. OK, that concludes. Let's try this one last time. It really was a cool demo. This is entirely Mesh's fault, though, nothing to do with Intel, so the blame goes on us. All right, well, let's finish up the talk and then take questions. Hey, right. Requesting access. OK. Whoop. Look at that. It woke up and I can remote desktop to it. Hooray! OK. applause deferred is better than no applause at all. I'll take it. So we'll wrap, and then we'll take some questions. So again, just quickly to be clear, in the CTP today, delegated authorization is available. Go for it. Party on. If those of you who don't have tokens, I have to access our CTP, we're restricting access for now. You can get them in the labs down in the big room. I have a few with me here, so don't swarm me. But I have at least a few to give out. And this whole business of creating a new device and provisioning it is not really supported. Again, if you're clever and you reverse engineer it, you can probably get it to work. But we're going to change it all and make it more programmer friendly going forward. So don't bet on it. And in the future, we just love to start the conversation right now about how to get involved and how to think about this. How do you want it to show up as programmability and show up as frameworks? How do you want to integrate in to the user experience? Where do you want to be on the device ring? Do you not? How much do you want to customize your icon? What do you want your device profile page to look like? Do you want to write applications, and how should those things be integrated in? There's lots of thinking to do there. And then certainly we have to think a lot about cross-platform support. We acknowledge that not every device in the world runs Windows. That's OK. We hope most of them do, but there are a few that don't. That's fine. And we want to find a way to help you access those devices as well. So some kind of a kit that we can give you so you can figure out how to easily bring that device online. We're interested in feedback into what that kit would look like and how much sort of support you'd want there. Summary, blah, blah, blah. I hope you're inspired. I hope you're thinking about what your applications can do. And I hope you're ready to go party with delegated auth. Related sessions, BB34 is right after this one at noon, downstairs in 153. So if you're interested in this whole notifications communications channel, John McIntyre, our group program manager for that area, is going to give a great talk on that. The other 3 talks, either you saw them or you missed them. But if you missed them, catch them online. Everything I said will be up there shortly. Last but not least, please do take the time to fill out evaluations. We get like 5% of people to fill out evals. These are actually really important because the entire PDC content team looks at them. They actually look at every single one. If a speaker gets terrible evals, they are not invited back to PDC. So if you don't want to hear me talk again, that's the best way to make it happen. Conversely, if you get really good evals, then we actually take speakers and say, hey, you're clearly connecting with audiences. Let's get you out there more. I like speaking. I'd like to be out there more. I'd appreciate your good evals, but it's important to be honest. So if you want me to stay home, put that in the eval too. I read all the verbatim comments. The content owner reads all the verbatim comments. And a couple of the other program managers in our team read all the comments. So that's a long plea to see if I can get above 5% evals. Let's see if it happens. Thank you. We can take Q&A, and we'll use the mic so it gets on the video. And then I think we have about 15 minutes, and then we've got to clear out for the next session.
Do you plan to have any certification or logo programs for devices?
Let me ask you this. Have you found logo and certification programs to be helpful thus far? No comment. OK. I would love to have a way to support partners who are using mesh and mesh services. I'm going to be honest and say that in my assessment, we have a mixed track record of whether our logo programs are as clear to users and as clear to our partners on the value they provide. So if we could find a really clear value statement, I would love to do that and help partners come along. That will require us to actually enumerate all the requirements, et cetera, et cetera. So it's down the line. Are there questions over yonder?
I came in late, so I apologize for this, but I have like a G1 phone. I want to be able to play with live mesh on it. But I saw at the end you said something about you can't create new devices or anything. I wasn't quite sure what that was all about.
Yeah, so what you could do today is go ahead and get one of those delegated authorization tokens. That will give you a token that you can use and do HTTP gets, put, post, delete from your G1 using whatever REST, if you use curl, I don't know, whatever library you want to use to do HTTP manipulation.
Okay.
What you cannot do is get a full device ID so that it shows up in the device ring. And we're not discriminating against the G1. You can't do that for any we just don't have a way to do it for any device right now.
So it just wouldn't show up in the
Yeah,
on the
that's right.
mesh, or?
Yeah, that's right. So you could pretend it's an application, basically, and say, hey, I want to go get some data using this authorization token.
Right.
But we don't have the process for creating the device ID, the device claim,
Right.
et cetera. And again,
So-
that's something we're working on.
So somebody gave me a card with the live mesh token. Is that what I need, or is there a separate token for delegated auth?
That token, both things are true. You need that token to log into the developer portal. Excuse me. When you log into the developer portal, you have a way to create applications. And when you create an application, you will get, and a user installs an application, you get a delegated auth token. So in the process of bootstrapping up one of your applications, you'll get a big token, and the portal will say, hey, put this token in your auth header.
Okay.
The token on your card would not work in an auth header.
Okay. Thanks.
Yep.
Hey, what's the roadmap for Microsoft devices and Live Mesh?
For Microsoft devices?
Yeah.
As of today, I haven't checked email, obviously, but if everything's going well, Windows Mobile 6 is supported right now. Yeah, we'll see. I will give you a heads up that we've only got a couple hundred of those. We're really limiting that because we're very conscious about screwing up people's data plans. So we're doing a very few installs of the mobile client to begin with until we make sure that it works in the real world. But that'll roll out over time. Beyond that, we would love to get Zoom. We'd love to get Xbox. The home server guys were here and showed 2 sessions with mesh integration. We're actively thinking through how and when that stuff should happen. But I've got nothing to promise other than we care. Is there another device you were thinking of?
No, actually, Zoom was the one.
Okay, so we'll get there.
So yeah, a question. In the Intel space, they're using vPro, for example, for out-of-band management, even if a PC is powered off. So does the technology that you identified in terms of their Wake LAN cards allow a PC to be powered off and powered on through mesh?
I'm looking for Brian. Where'd he go? Brian? He was sitting right there through the whole talk. There's a gentleman named Brian Rowe from Intel who was here and now is not here. So
Okay, so that would be a cool
I
thing.
can't answer
Yeah, that would be a cool thing. If one of my kids shuts down the PC at home, goes out for the evening, I'd like to get to it, see that it's on mesh, and then ask it to boot itself.
I agree 100%.
Perfect.
Cool
Okay,
thing.
good.
I have never heard of that technology. I will make sure we.
It's
next time we
vPro.
meet-
Yeah.
Okay. Next
Go for it.
time we meet with Brian, I'll make sure we ask about
Second
that.
one is, and this may be just something I'm not.
The comment
Well-
is vPro today is limited to the subnet, but I would.
However, Intel has been working with some of the home gateway manufacturers to be able to pass through, and I'm wondering if the home server folks are doing something very similar. So that's a bigger question than you can answer. But anyway, that's one, I'd like to reach that device even if it's powered off.
I would like
through
that
mesh.
also.
Second one is does a user have to be logged on and have launched mesh on the Windows PC in order to access mesh, or
No.
can it run as a service?
It does run as a service. So there's actually 2 parts, and this is, we need to think through this a little bit more today. When you install the mesh client today, there are actually 2 exes that come down on the system. Well, there's actually 3. But one of them is a thing that we call the Live Mesh Remote Services. That actually runs as a service under the system account. That thing is responsible for publishing the presence that says, hey, the device is available for remote desktop. And it actually listens to the queue for remote desktop connections. There's a separate process, which is the live operating environment. That runs in a per-user context. In some ways, that's not ideal, because if you're not signed in, and that's the process that says, I'm available for sync. We know that's not ideal, because you want maybe to sync even when a user's not logged in. The flip side is that by doing it per user, you can install that without having admin rights. We worked really hard on that. So if you're not going to install the remote desktop stuff, you can install the mesh runtime per user, never touching any admin, no UAC prompts. So we're proud of that. We're trying to figure out the right mix of how you sort of let people kind of power up and say, yeah, I want to be an admin. I want this thing to run all the time. The home server guys in their demo actually showed both the remote service and the synchronization executable running as a service. So we're working on it.
Okay, thanks.
Thanks.
Kind of a specific question. Is it possible to run the live, what's it called now? The new live framework client and the live mesh client? So you're running on the dev cloud and the I've already kind of run into that.
I am supposed to say no.
Okay. Would have been nice to know before I orphaned all those folders out there.
Yeah, so he's sort of pointing out something, which is that our developer CTP today is actually not part of mesh.com. There's www.mesh.com, and then there's developer.mesh-ctp.com. We have very intentionally segregated those two things because we don't want, let me say it this way. I was in charge of our final security review for this product. I'm confident we've got everything right, but I'm not so confident that I want to open up the world to write applications against all of our user data just yet. So we're going to start by putting this sandbox up and say you can write applications and the only data you can get to are to other developers and the people who, well, if everything works, the only data you can get to is the data of the user who installed you. But even in the worst case, if there is some kind of an issue that we haven't found yet, you're only able to impact that separate developer cloud. You can't reach out to the end user cloud. And so if you want to be both an end user and a developer, you have to have accounts in both places. There is no supported way to run them both side by side. If you happen to come by the booth later today and you happen to look at one of the machines, you might find a way that it's possible to do it. We've been experimenting with it. It is not, there's some real weirdness, but it's possible.
So would you recommend something simple like a VM to do your dev for your dev environment then?
Sorry?
Something like a VM for your dev environment,
Yeah.
something simple like that. Okay,
That's
thank you.
exactly what I'd recommend. Or you can do development without installing the client, right? So if you're doing a direct service integration, you don't need any client bits at all, which is fine. If you want to program against that local guy, a VM would be a good idea. Okay, thank you all for your time. Thanks for coming to PDC.